right, check out examples 3 and 4 here. We got a kind of another a radical equation here where we got some sort of nth root, square root in this case, of 2x plus 8. So there's a little extra stuff underneath the radical this time as opposed to our first two examples, plus some extra stuff kind of going on outside of the root, which we need to take care of. And then example 4 is very similar, it's just dealing with a fifth root. So let's check out, let's see what happens here. We do want to still isolate the radical, so whatever the square root, get this by itself right here alone. So we'd want to add 4 to both sides. So we'll add 4 to both sides. If we do that, we'll end up with the square root of 2x plus 8 is equal to 6 plus 4 is 10. All right. Then it's time to address the root. Okay, once we can get it by itself, then we need to take and raise both sides to the appropriate power. In this case, the appropriate power is going to be to square both sides. So I'm going to raise both sides to the second power. And again, we know that because the square root does have a little index of 2 there. You just never write it. It's just assumed a 2. Kind of one of the few times in math where you assume a 2. But the square root then cancels out with the power of 2 or the square, and we get just 2x plus 8 is now equal to 10 squared comes out to be 100. All right, and then what we want to do is solve for x. So it's kind of just a linear example from here. Let's go ahead and minus 8 from both sides. We'll get 2x then is equal to 92. And then we need to divide both sides by 2. So we'll divide both sides by 2 here. We'll get x equals. And that's our goal always when we're solving is to get things down to be just x equals a number, or as close to a number as we can get, I guess. And then 90 divided by 2 is 45, and 2 divided by 2 is 1. So 45 plus 1 gives me 46. As a final potential answer, we do want to check that. And I was going to demonstrate here on the calculator how we can check that using kind of the stow button and the x variable without having to go into the graph and all that fun stuff. So here's what we can do. We can hit type in the number that you want and just type in 46. That's what we think our answer is. We're going to hit this little store button right here, STO. So we're going to store that as our x variable. Okay? And then obviously every time I hit x now, it's going to plug a 46 in it. It's kind of handy to use for, kind of evaluating things. So it's just type your number in, store the variable you want, and then you can go from there. And you can store other variables too, y and z, if you want. But we'll just type this in, the square root of second square root of 2x plus 8, 2x plus 8, and then minus 4. And what we'd want to see here is this side, we want this to be equal to 6. If this answer actually works and we can plug 46 into here, this would all come out to be equal to 6. So if I hit enter, and it plugs a 46 in for my x there, it's going to plug one in there. We do get 6, so we do see that that does check out there. When we do our check, we get 6 equals 6. This side equals 6, this side equals 6. Our answer's good. We're good to go. So it's just a quick way to go back and check your answer. There's other ways of doing that too with the graphs and charts and that kind of stuff, but I like that one just because you don't have to mess around with the y equals and go through that whole process of getting something graphed and then finding the zeros and all that fun stuff. We will use the other graphic and calculator features here in a little bit, but right now this is good enough. Let's check this one out. We got the fifth root of 2x plus 2 plus 5 equals 9. Again, very similar problem. We'd want to minus 5 from both sides here first. We're going to isolate that root. Okay. We'll get the fifth root then is 2x plus 2 equals 4. And then we'll address the power, and the appropriate power this time, we get the fifth root here, so the appropriate power is going to be the power of 5. So we'll raise both sides up to the fifth power. The fifth root and the fifth power cancel each other out. And we'll get 2x then. We can bring down just the 2x plus 2 is now equal to 4 to the fifth power. So 4 to the fifth is 1024. So we'll get 1024, and then again, like I said, it's just linear from here on out, so it's pretty straightforward. Go ahead and minus 2 from both sides. We'll end up with 2x being equal to 1024 minus 2 is going to give me 1022, and then we'll divide both sides by 2. So we're just going to cut it in half here. We'll get x is then equal to, let's see, half of 1,000 is 500, half of 22 is 11, so we get 511. 511. Okay, so good. Checks out there. I'm just going to check that answer too. 511. Let's store that as x. Okay, and then we'll type it in. Okay, so remember to type in a fifth root You can do the x the root option, or we can do it as the 1/5 power, which is how I'm going to demonstrate it here. So 2x plus 2. And remember, the calculator is going to plug 511 in for x right now. So I'm going to raise that up to the 1/5 power. That's the same thing as that fifth root right there. Okay, so we get the 2x plus 2 to the fifth root. We still need to add 5 to that, and it should equal the 9 that's on the other side. So it does check out. 511 is a good, valid solution. We're good to go. Now, again, this isn't telling us that we have every single answer that there might possibly be, but it's telling us the ones that we did find do work.